Okay, let's start the Tuesday class on the 13th week. That is the last week, and this the one before the last class. I've told you last week that we have no more subjects to discuss, to introduce. So the study program is completed. And today, my idea today is just to present or discuss with you and answering questions regarding the third assignment. That is really important and strange assignment because there is little to code and very much to organize and to cooperate, since it's a cooperative assignment. You have to work all together. So I want to discuss it. The contents are already on our web, and there was also, I published it yesterday, a short video trying to explain, to introduce, or to outline the important facts about that, and we will do together. Another thing we can do today is just to review very briefly the subjects of the study program. I will also write an index, and I will put at the end of our web, just to be sure that you do not miss some of the topics that are sometimes are clear in our web, sometimes are inside a folder with name something like Wednesday class, but inside there are slides and so on. So I will try to make it clear with the sort of index in general, and to explain how we organize the final exam, everything. But the most important topic now is the third assignment. The third assignment is a cooperative assignment, since you have to work all together. All together means that you have to meet and to decide together rules for coding. Every one of you has to implement the same algorithm, the same program. I hope that you will not exchange directly code, but it's very difficult to, if we were in class, in a physical class, it could be different. So I assume that you discuss all together detailed specifications, so that all your programs can communicate each other, but you carry out you alone by your own your homework, and you will have to upload, so to deliver and to upload personally one by one the code. I know that some of the codes will be in any case will be shared, because while you are discussing, you also discuss so deep details in coding that codes can be similar, but I assume they are different, and we will, me and the assistant teacher that you don't know yet, but will put a lot of effort in looking at your codes and seeing they're not exactly copy and paste. So we assume that there are some differences. Also, making artificial differences is a sort of skill. So in any case, do what you want, but you have to organize. In any case, the problem is under-specified. So not all the specifications are completed. As if you have read the paper, you have seen that. So you have to decide together many details, and you have to run on your own virtual machine your program, and all your programs must be able to communicate with any other program, because all your programs will connect using socket to any other programs that you did. So that's the idea of cooperative design. How many you are? I've seen from, well, since if you want to do the exam in January or February, you must have delivered the first and second assignment. I've seen that there are about more or less 30 first assignments uploaded. And probably this is the number of you who decide to do the exam in January or February. I suppose that the number will be similar in the second. So assume that more or less the group that will solve this cooperative assignment is 30 students. It's up to you, everything in particular. You may decide that it is better to divide into groups, equal groups, 15, for example. They may be put in relationship with the fact that there are two scheduled dates for the exam on January and February. Don't remember the day, but probably it's January 16th or something like that, and February 18th. Well, in any case, more or less at the mid of January, mid of February. Maybe the two groups are related to the two different exams. I don't know. It's up to you. You decide. So the first thing you have to do is to meet all together. I mean, all the students who are planning to pass the exam in January or February, and start to decide a hierarchy of decisions. The first one is one whole group or two smaller groups. If you are 30, 15 is good. Less than 15 is too few. So the decision is a Boolean decision. A full group or two groups, one half of the amount of people, okay? This is the first. Then you have to discuss how to translate the specification written in English in my document into diagrams. And that's exactly what I've pushed you to do in the last weeks, in which I'm asking you to just to draw the organization of the software architecture. The problem I'm asking you to solve is simple from algorithmic point of view. And in particular, you may reuse a lot of software, of pieces of software you have developed the first and second assignment, and also possibly during free exercises in the classroom. So it's based on sockets, because all nodes of my game communicate each other using sockets. They will measure time of the transmission, similar to the first assignment. They are asked, all the nodes, to build a struct record accumulating node ID, time of reception, time of transmission, and so on. So it's similar to what happened in the first assignment. Sockets are similar to what you have done or you are doing in the second assignment. Forking, if you need to use that, you are absolutely skilled in using the fork primitive. Probably you don't need pipes, but you can use pipes. You can use everything, but in principle it's simple. But you have to organize all the scheme. You have to use the virtual machine as an internet server and client at the same time, because all nodes communicating are completely symmetrical. You have to decide and to organize the first initial non-symmetry, because you have to decide which is the node that starts what I call turns, or the turns, what I mean, the single parts, single event of communicating. It can be done in several ways, and finally you have to deliver all the results to a central server that is to be defined, because I will build the server to receive your messages once you have defined exactly the protocol that I will use to receive your data. So it's a group project. It's anticipating what you will do in the second semester, working together in groups, because working in groups is part of the skills that this degree is wants to give to you, to teach to you how to, and so here is the assignment, and you can start working on, and the schedule of your meetings that probably or surely you have to meet is up to you. You will decide. I don't know with which organization, if you decide to have a group leader, usually it's a good idea. It's not the chief, not the boss of the whole game, but it's just the secretary of the group, who takes care of the schedule of the, and give also the minutes. The minutes that means something written or something as a conclusion, a decision taken in meetings and so on. So it's a real job. You must work exactly in the same way all professional people are working in research or company activities. Okay. Shall I start commenting the document, or do you have questions? So I try to share the screen. Maybe this time I succeed. Yes, you can see the screen.
Yes, we can see the screen.
Yes.
Final cooperative assignment. Well, version 1.3. That means that we will schedule, I will propose to you, schedule periodic meeting if it is the case. So, or well, my availability to meet you at least one per week, also during the holidays. In Italy, we will not have many holidays. Probably we will have a new lockdown. So the good idea to stay home and code. And in any case, so if you have objections, comments, or proposals to change what I've written, or something, some inconsistency, something wrong, and so on, please tell me, and I will increase the version number with a minor number or a major number. So that's the reason why it's version 1.3. I've been working with the coordinator, Professor Mastro Giovanni, so I started with 1.0 and now I'm published the 1.3. So probably let's start from the drawing. It's not with no comments, nothing written inside, because it's just to trying to use it for just for notes, for suggestions. So here are 30 nodes in virtual machine, in Azure virtual machines. So here there are not 30, just for simplicity. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's okay. That is the same thing. So here there are 1, 2, 3, 4, 5, 6, 7, well, 8 students, each one in a virtual machine with the public address. And please organize your virtual machine so that the public address does not change. So it's a static address. So, and you have to, well, we will build together. I will ask you the, I think I will do tomorrow. I will write to all of you and asking all of you who is as the idea of doing the exam in January and February and using those. And so this will be the list of names. Of course, all of them must be must have delivered the first and second assignments. Otherwise, they cannot do the exam. And in any case, you can change your idea. So you can say, I'm supposing to finish all the 3 assignments, but at the end I will decide to give up. So it's no problem in saying that. And we will build a list of names and IP address, a table. And this will be the table that I've commented in the video and is addressed here. So the list of IP is known to all. Nodes can be numbered if you decide to number instead of using the explicit address. So at the beginning, here are 8 students. One of them randomly will be the turn leader. Just the turn leader is just the fact that at the beginning it will start the first loop, and at the end it will send the statistics to the server. So it's the only job for the turn leader, but you have to choose randomly. So you have also to solve this problem. How? 8 equal or very similar equivalent processes can vote and decide which is randomly, which is the turn leader. It doesn't matter who is. The important thing is that it must be chosen using an algorithm that guarantees that is randomly chosen. The turn leader just sends a message to one of nodes randomly chosen. Sorry, I have to. Is one of your teachers, but I will call you afterwards. And the important thing, you mark the time of delivering, and it will record the time of reception. So as in this first assignment, the final aim of the game is just to have statistics of milliseconds or nanoseconds or seconds needed to exchange data between the virtual machines in a random fashion. So the second node has 2 times and it doesn't measure anything. It just puts in a record that there are 2 times. And the nodes, the first one and its identity. The second node chooses randomly another, and T3, that is different from T2, T4, that is a new time, but T3 T3 is not T2, because you have to ask the system which are the real time of these events, because you're computing inside, so they will be very similar but not equal. T3 and T4, and so on and so forth. So at the end, the last one will send the its identity, time, and this will measure. Of course, since every node chooses randomly the successor, so I mean the node to which to send, it has also to care that every node must be visited only one time. If randomly choosing this node decides to send back to the previous one, or another node chooses a node that already had been visited, it just changes randomly the choice, so that at the end of the turn, all 8 nodes have been visited once. You repeat 10 times this, not with the same nodes, but every time you change randomly nodes. So every node will be accessed, but in a random choice for 10 times. That's the internal loop. At the end of this, the turn leader sends the measurements. In this case, can compute a sort of statistic. Well, a statistic. You decide which kind of statistics. Considering the fact that we want to measure the performance of this network of processes in different situations, and that's the idea of randomly choosing the paths, so we can change many times, and we have an average time for communication between one node and another node in Asia, in your case. Maybe time, so what's or better, the bandwidth. Better, since the bandwidth is referred to the amount of bytes you have transferred, and time is just a measure of time. So bandwidth is a ratio between the length of messages and time of delivery. So it can be compared with other measurements. So bandwidth is a good choice. You do this, and you repeat 10 times all the experiments. So choosing 10 times randomly the turn leader, and we assume that the turn leader changes. So we have 10 different turn leaders, and each turn leader carries out 10 times, or organizes 10 times this work. Questions about this?
Yeah, I have a question. So it's supposed to be completely, let's say, parallel as an infrastructure. So we cannot have another central server, for example, that decides that
you cannot.
So we have to find a way to
completely parallel, completely distributed. So you 10, in this case 8 students will start one by one their programs, their processes, And when you all know that all processes are running, the game starts.
Okay, thank you. And yeah, each node is supposed to be practically identical to each other node, so none of them has
identical.
Okay.
If you decide that it is better to have a different node just to kick off all nodes to start all together, or to choose randomly, you can do that. I think it's not necessary, but any choice is okay. The simplest case is from the coding point of view is that each node is identical to every other node. In that case, you have to break the symmetry just for starting. Since you start when you know that all nodes are computing, and as the first act of the process is the choice, that is non-symmetrical choice of the turn leader. That can be done simply in several ways. I don't want to suggest you anything because I want you to solve this. So it's the only asymmetry that is necessary, just to know that all nodes are running. Otherwise, the game cannot start. Since we have the table, the initial table with all nodes that participate to the game. That's important. So it's not so complex to check if all nodes are running.
Yeah, the asymmetry I was looking for was just for that to check that each one was running and to decide which one to start at random each time. Because and that asymmetry simplifies a lot because implementing a pure parallel system with something like token ring.
You know that this table, well, is not shared because we don't have a shared memory, but every node has a copy of this table that is stable, public, cannot change. So any node must trust in this table. So any node can also check if all these processes are running. Personally, I suggest this. It's a dumb method, but is very effective and simple. Okay?
Okay, thank you.
I stop sharing. Well, we have to organize some practical aspects, but in principle, my suggestion is that you start working as soon as possible. And since we have time today, and I'm harboring the fact that is almost the last class, I will give you half an hour just for pure organization, for deciding or for reporting me what can I do for you. For example, with periodic meeting, availability to periodic meeting, not necessarily periodic meeting that you must attend. You have holidays and you have to study, but in any case, I think it's probably is more useful with respect to being available for answering to calls. I can do in any case. And those of you, sorry, those of you who are asking me questions in these days for assignments and so on know that usually I using instant messaging in Skype. It's the best way for me because I read from the cellular phone, and so we meet in a very short time after we are having contact. And this will be in any case possible. In any case, it's not an alternative. What I think may be useful to have a series of scheduled appointments in which you can be certain that that we can meet if there are something have to discuss or to something like that. So one thing we can do is just this. I promise you that I will give you every week just at least one day in which to have a possible meeting for question and answer. First subject. The other subject is just how you will organize yourself in a whole group or in 2 groups. You choose and you decide how to go on and what you need to do that. I think you don't need that I organize Zoom meetings or Teams meetings. Personally, I hate Teams, so you see that I barely use Teams as less as possible. But using Google Meet, everything. I don't think it is necessary that I organize meetings. I can, in any case. I think you have all the tools to do that. So that the first thing is to know each other, the participants of the group. I will ask you in Aula Web to log in and say which are the students that foresee that they will attempt to do the exam in January and February. This is not with no problems in general if they give up, absolutely not. Just to build the map of the students, and together with the names, well, all the email. It's not necessary to have the real names, the emails, to have the IP addresses. That's the table. The table is fundamental. So addresses to be reached by email, Zoom, Teams, or anything, just organized group. IP addresses to reach the machines, the virtual machines. They're important as much as the students in this work. Okay. Personally, I will propose to give you half an hour to discuss this if you want. You think it's a good idea?
Yes, and Professor, I would like to ask if there is a deadline for this assignment.
The night before the exam.
Oh, thank you.
Well, in any case, we have to also to organize a demonstrator for that. But I will separate the. We'll consider different the legal problem of having uploaded the personal result. The demonstration may be also just after the exam, is not so important, but just in those days. So I want to participate when you run the machine. So I want to hear the rumble of the gears of the Azure machines when you do that. Okay, but in any case, you have to upload the code before the date of the exam. The exam, I don't have many other comments on the test. I've also explained that it is a test in Aula Web with you have to choose the right answer. And if we have time, or also tomorrow, we can browse all the subjects in Aula Web to see, because there will be at least one question for any subject. And so I want to just it is clear which are the subjects exactly. There some additional material in Aula Web that is not considered. This was just an additional material for your culture or for helping you to work. It's not necessary to something that on which you must answer questions on an exam. For example, the shell, using the shell. I've uploaded much material because it's a professional, good topic, good skill using the shell, and also useful for your assignment. But I will make no questions about the shell commands and how to organize. Just an example. So it's a good idea for me to give you an index of all the subjects. I will. But now I'm a bit anxious regarding the third assignment. So I want you to organize in a room, in a closed room, so I will not participate. And just proposing you to discuss how to organize that, and if there are questions to solve or problems to solve by my side. So if you see that there's something that will be decided or in a different way. It's okay for you to do that? No objection? First, I share the screen. So I'll allow you to share the screen and go inside you are 23 in one room. Go. Good. So you are back. Well, I hope that it's been useful for you and was not a waste of time. Did you discuss what to do and how to organize yourself?
Yes, we discussed. We made a group for this assignment, and
okay, so you are autonomous in going on the project.
Yes.
Good. In any case, tomorrow there will be a class, as I told you, just for answering questions. I will publish my availabilities for periodic meetings if it is the case, and with additional instructions or something like that being used. But during the work, probably there are things that we can, information that we must exchange, and in particular, I will advise you that sometimes I have to know the protocol for receiving all the data, so you must detail, and I will as soon as I have the list of you who participate to the group, I will write to that closed list of participants instead of writing to all students in our web that maybe are not interested in that. Okay, good. One thing we can, well, questions of any kind? No question now. There was something that I forgot, but I wanted just to say to you, just 5 minutes, and it's a problem that arose in a discussion with some of you for regarding the second assignment. Let me share the screen. In the second assignment, there was some of you asked, you see my scratch pad with the sheet of paper, okay?
Yes, we can see it.
You can see. The problem was regarding the second assignment. Some of you said, well, is it possible to open a new shell specific connected to the, you remember there were two groups of processes, one for the operator and the process that was at the control of the gantry of the joist, and with the processes H and S and the socket server and the H process. Some of you asked, I would like to have a console open connecting the H process, but I cannot use that. So the idea was the good idea of having two separate shells, one connected to the process for commands and for the feedback, and another shell completely connected to standard in, standard out of, for example, the H process to have the information about the motor and so on. Is it possible? No, the answer is it is not possible if you work on the, well, it is possible if you work on the same, on a local machine. It is not possible if you work on the, in the virtual machine. The answer is, so the console, you remember the console application, the console process is one that you can run and runs a shell. So you have a different, completely different shell hierarchy with the, and you can talk directly with the console with the different shell with respect to the shell that we use to run the process that in its turn run the console. The problem is that the console usually opens a window, opens a new window, and probably you have seen that the new window is also from a graphical point of view is different from the main window with your shell, different colors with different characters and so on. So the new window is a process, and in the new window, the console starts a new shell. So you have a brand new shell and you can do everything. Processes running in this shell can talk with the processes that run on your native shell. The important thing is that you open a window. What does it mean you open a window? When you run a shell, or when you're using a shell, you digit the command shell or bash or shell, you in the same window, a new shell opens. In the shell window, if you using the tab, you open a new tab, you have a new shell, but is in the same window. What is a window? Window is a graphical entity that is offered to you by your Linux or by your Windows system or by your OS and so on. And in Linux and Unix, a daemon go back to the Unix Linux architecture, and you know what maybe you know what is a daemon. A daemon is a system process running in the kernel, so as a kernel process that carries out some services, not necessarily in the kernel space. There are daemons that run in user space. A daemon is a service. In some other operating system are called services. In Android are called services. One of the daemons is the graphic the standard graphic server in Linux, Unix, Linux is called X server. The X server is the one that offers you the main window with all icons, command, click and point, and everything, supports the mouse and everything. So when you run a process, your own process, your processes do not use the X server, the graphical interface. They use simply the shell. The shell is inside, is an entity offered by the X server. If you don't run the daemon that is called X, you can, and in robotics is very popular doing that, you can have a Linux without the daemon graphics server. Not the only one, but the most popular one. And so we have a Linux able to run a shell directly in a text mode without the window, the shell window. So we have only one shell. You cannot open a new shell. You cannot open a new tab on the shell console. You don't have tabs. You don't have windows. And you cannot run console. Console just asks the Windows system, so the daemon running the X server, to open a window to connect to a shell. So console is a typical process that directly uses the graphic interface. Why I said that is popular in robotics that you don't have the X system, because once you have a so-called embedded system in which you tailor or customize your kernel so it is as small as possible and runs in real time, you don't need the graphical interface to interact with it. You download processes, applications, and you watch them run and you read the log files, but you don't interact directly. So you, and if you are able, you are interested in, you can bootstrap your Linux in your machine, preventing that it runs the X server. So you can have the original Unix of 30 years ago, in which there was no graphical subsystem, and you have just one big shell with a dark screen. So that's the idea. So in conclusion, why you cannot use the console in the virtual machine on Azure? Because Azure doesn't have the X server, doesn't have graphical server. So all graphics in the Unix Linux architecture are carried out, are supported by a daemon that is the graphic server. It's similar to what happens in Windows, but in Windows the graphic server is embedded in the kernel and not separate, so you cannot have a Windows without, or it's not easy to have Windows shutting down the graphic interface. Is based on the graphic interface, is in a sense is deeply inside the kernel. In Linux, Unix has made the different choice. It's a good choice for automation for robotics, just to have the graphic system just as a separate element that you can run or not if you don't need it. In the Azure virtual machine, there's no graphical interface, so the console runs, but as soon as it runs, it says, it complains that it cannot connect to a window, a graphics server. That's the explanation of that. I wanted you to know the reason why they're strongly related to the architecture of the system we use, and you will keep on using in the next semester, next year, and in the future, maybe not only this one, of course, but it's important to know, because in computer, when you use computer, everything must have an answer. Nothing must happen magically. You cannot say it doesn't work, I don't know why. So, okay, that's the explanation about the using the console. If you use console program, the console application inside your local machine surely have the X server, and so it works. But once you transfer on the virtual machine, it runs, but it complains that it cannot connect to the X server. And you can understand why. If the virtual machine had the virtual server should have a protocol just to talk with our system, sending and receiving all graphical commands. That is a lot of data. It requires a lot of bandwidth, so it is not provided to that. And last information about that, the local server, I didn't know, I want to assert it in this drawing. The local server, it's really interesting, a strategic problem. You connect, a process connects to the graphics server, uses socket. With the port, I don't remember the port, but you connect using a socket. So you connect to the local server for your GUI when you talk with your system, just like we're talking with the remote graphical server. And it's so interesting that you, in a local network, for example, it's very easy to open a window on a Unix, Linux machine, not my machine, my local machine, but a machine connected to the local network, because you can talk with the X server of another machine just using the socket with a specific protocol. You can find Googling the network, which is the protocol for the X server. Normally, this port is closed for safety reason, but you may decide to have two computers or more than two computers to share windows each other, because the Windows server is just a server. It's just a server, and this, unfortunately, is one of the reasons games are not so popular on Unix, Linux machines, because the communication between your application, this game application that strongly uses graphics, is slower with respect to a Windows server embedded in the system, in the kernel, directly accessed by the process. You have to you have a protocol, you have a connection, you have to send data and receive data and so on. And so it's more difficult to have fast in general graphic application. So stop. Oh, you know all the story. Well, this was the last theoretical content I wanted to transfer to you. You met, so you have started your organization. One thing I can do now, I think in 15 minutes, so we will finish soon, is just to browse very quickly Aula Web. So just to remind you which are the subjects that you have to know for the exam. So share the screen. No, this is, okay, the exam. Well, that's okay, this is the advanced in robot programming. At the end, I will put just the index. So I'm sure that you will not miss anything. First week, well, was introductory material, so probably, I don't know here. Let me Okay, oh no, it's really important. Unix, Linux, first pack of slides. I will not browse all slides. Unix, Linux basics. Can you see the slide?
Yes, I can see this slide.
Yeah.
Remember,
Yes, we can.
it was the first pack. And introduction Unix kernel, the first pack. We have different other. I cannot close this. Okay. So go back. Yeah, we go on with this. This is, you remember there were the slides with regarding Linux architecture. You have the slides, you have the recorded class, also examples. So this is material that you must study and ready to answer questions. My idea is to have at least one question for each topic. Was week 3. Oh, no shell commands. Okay, no shell. Well, this I remember when I did this scratch. I think it's something that is not something to be studied by itself, but just a support for the other material. Okay. And here is a series of the packs of syscalls. You remember that you have syscalls 1, and then you have you must find until 7, if I remember all the numbers, all the in the middle. The number 2, as to say, pipes or being delayed with respect to files, but doesn't matter. So you can find no shell programming, pipes here, files. Sometimes I remind you that some slides have been declared obsolete because I've made some upgrade or some corrections, but I didn't erase because some of you might use the AMA note, so in that case it would be lost, so it doesn't matter. But in any case, if there is a new version of a document, the old document is marked as obsolete and the new version is declared as superseding the previous one. Files mode is just an additional information just for coding, for all the parameters or values to put on the open, close, and so on. Exercises, okay. So for solution by Fedotzi. So you don't have to study that, but it's a good example to read. Is it possible that in the test exam there will be just a small piece of code regarding system calls or using system calls, and to explain what it does? So you will not ask it to write code, but to understand and explain code or answering questions about that code. Yes, is fairly possible. Select, absolutely important. You see here in that case that there is a document that is obsolete in the signals. Don't use this, previous obsolete. Use the updated version in week 7. So don't use an obsolete document. Select, new version of the select. Creating dynamic shells at the console. I will not ask anything about the console in the exam. not the console by itself. I wanted that you know how to use that, and with the what I've explained now. Signals, updated version, okay. Oh, sig weight. I didn't put the sig weight. That can be useful in some cases. Well, not for so important for your exam, but I will update the version using the sig weight, adding the sig weight. Sockets, with the new version of sockets updated is here. You know, sockets are really important. Tutorials and examples, absolutely yes. You must know all. Also, what you didn't use in your coding, in particular, the UDP protocol. I decided not to ask you to write code using the UDP protocol, but only TCP. Well, it's not forbidden. If you decide to use UDP in your experiment, in your cooperative experiment, very good, no problem. We didn't. You have also examples to do that, so you choose. I'm not asked explicitly to use UDP, but you must know how to use UDP and what's the difference between UDP and TCP. File descriptors internals, you must know this, which is the internal how the file descriptor is managed inside the kernel. Files on disk is not, is an additional information. No questions will be delivered. First assignment, I think that, well, shared memory. Shared memory is the last pack of slide, and you must 7, so not 6, 7. Shared so 1, 2, 3, 4, 5, 7 shared memory. Shared memory is important. You are not able, well, I don't know, maybe you are. You are not, I'm not asked you to write coding with using shared memory, so you must have information. We must know what is the shared memory, what is it for, which are the system calls for using the shared memory. And last, this one, I will semaphore. It's a subject that is partially in common with the real-time system. And in this slide, there are only principles of definition of a semaphore, what a semaphore is, with some examples. One of the example, the most complex example, is the dining philosophers that you also have faced during class. And there are other more complex examples like multiple readers and writer and the roller coaster and so on. So I will write in the index that I assume that you know what is a semaphore, how it must be used for accessing a shared memory, how it can be used for also as a counter in the problem of a bounded buffer, and in the case, for example, of dining philosophers, which is just one of the possible solutions using a semaphore for accessing a shared resource. But so the basic concept regarding semaphore. If you need more information about semaphore, browse the network and you will find plenty of documents regarding semaphore. That is a very basic topic in computer engineering, computer science. So that's all. I will put the index with the information also regarding which are the semaphore concept, the 4 semaphore concepts in those slides that I'm asking you to know. So explicitly, I will say, I think that you have all the information now to conclude your preparation. So, if there are no questions, I can ask you something very strange now. May I ask you, for those of you who want to do that, to open the camera so we can have a memory snapshot, a memory picture of the core part of the students who decided to attend all the classes in the first semester and probably to pass the exam at the end of the first semester, just to have a picture, so to live just like we were on a class and we are all together and we take a camera, a smartphone and taking a picture all together. I am the first one, and I don't know if also in your case I am in the upper left corner, or for you is different. I see myself, I watch myself, I see in the upper left corner. So, okay. I remind you that tomorrow I will write in our web. There will be the class in any case, with just for answering any kind of questions regarding the exam or questions regarding the assignment for those of you who are still struggling with the assignments or any kind of question. I only ask you, if you want to attend tomorrow, just to connect in time, so we don't wait. I don't wait a lot of time if nobody is there, or if other people has finished working. Well, if Gianluca Piquet, Ilenia D'Angelo, Oliver Xavier, yes, it's beautiful to have just the last 4 students. You know each other, I suppose. If you are meeting, if you meet, probably you know each other, or you're starting to know each other. Okay, that's enough. That's enough. Alice Nardelli, I was waiting for you. Okay, so this is the memory picture of the ARP. If this is the last official class, have a good time, enjoy your work. I think you can enjoy your work. It's interesting. And for this semester, not only for this course, for the next semester, for the third, and for the big thesis at the end. In any case, not only me, we all my colleagues are the same attitude, so we can help you in any situation. So many of you know that if you write on Skype, usually I answer immediately, and we can have a meeting immediately after. Okay. I forgot. You will have a sort of a simulation of the final exam at the beginning of January. So just you can do at home, of course, and try just to have a look of what is the kind of exam I'm expecting from you. Okay, bye-bye. Have a good time. Good holidays if we don't meet again. For those of you who want, tomorrow. Okay, bye.
Bye. Thank you. Bye.
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 Thank you, Professor. Goodbye.
Thank you, Professor.
Thank
Goodbye.
you.